The topic of the session, the chapter 5, is quadratic equations. The quadratic equations are also one of the most important concepts in mathematics as the linear equations. As we have discussed about linear equation is a linear polynomial equated to 0. Similarly, I can say a quadratic equation is a quadratic polynomial equated to 0. And then let's see how it has come into existence in mathematics. Say for example, I had a rectangular plot whose area is 800 meters square. To start with, quadratic equations. Now, importance of quadratic equations is that we use this in many branches of other topics, even in science, where this is the most important concept. So let's see its origin. So for example, I have a rectangular plot whose area is 800 kilometers square, or I say it is 1600 meters square is the area of this rectangular plot. Then I know the length, but I have to adjust the width. Then let's see how we can do that using quadratic equations. So for example, a rectangular plot with area 1600 meters square is given to be with its length 4 times that of breadth, or I can say in addition to 4, it is added with 4 to that of width, so that when I take my width as x, then my length is x plus 4. If this is the minimum information given in a rectangular plot, then I can find the length and width using a quadratic equation. Then let's see how a quadratic equation is generated from this introductional problem. Now, as we know that the area of rectangle here is given to be 1600 meters square, then I next use the area of the rectangle, which is length times its width. So length being x plus 4 times of width being x would finally give me 1600 meters square, which in turn gives me x squared plus 4x minus 1600 equal to 0. So this is how I get when I take all the variables and all the constants to the left and only keeping 0 on the right hand side. Now, such equations which I obtain in mathematics for the given situational problem of a rectangular plot is called a quadratic equation. Quadratic because the highest degree is 2. So a quadratic polynomial, when I equate to 0, is on the whole called a quadratic equation. So we are going to study the different properties in quadratic equation in this session. So let's start with the basic definition of what is a quadratic equation in mathematical definition. A quadratic equation, what is it in mathematical definition? A quadratic equation, if we understand in the general form, it's a quadratic polynomial equated to 0. Of course, a quadratic polynomial in variable x, if I equate that to 0, then that equation is called a quadratic equation. And a quadratic polynomial is already discussed in the previous sessions, where a polynomial of degree 2 is said to be a quadratic polynomial. Now, if I take the quadratic polynomial in general form, then I assume the quadratic polynomial in general form as ax squared plus bx plus c equal to 0. This is called a quadratic equation in general form. And the condition here is that a is not equal to 0 and each of a, b, c are real numbers, and here x is the unknown, which is the variable. So the variable here is identified to be x. Is how I define the quadratic equation in X. This is the basic definition of quadratic equation in general form. Now, as we have seen that a linear equation has only one solution, then the quadratic equation has two solutions. A cubic equation has three solutions, so on and so forth. A polynomial of degree n has n solutions. Therefore, we always identify the two solutions for quadratic equation by using various properties, which we're going to discuss in the next sessions. So how to find the value of x is the next biggest question in this. How to find the unknown x? What are the different methods of finding x is what we're going to see, which is called finding of solution of quadratic equation. To start with an example for this is 2x squared minus 5x plus 6 equal to 0 is an example of a quadratic equation where the value of a is identified to be 2 because I compare this with the standard form of the quadratic equation, which is ax squared plus bx plus c equal to 0. Then b is minus 5 and c is 6 and the variable x is x. So this is clearly an example of a quadratic equation. But if I take 0x squared minus 5x plus 6, this is not a quadratic equation because this fails with this condition, a equal to 0. That implies not a quadratic. This cannot be a quadratic, is how I understand the quadratic equation with each of its basic definitions. So now that we have studied about quadratic equations, let's see where is quadratic equation applied in real life. Where do we use in the daily life is very important because we use this in various branches of science, especially physics. So applications of quadratics. Quadratic equations in daily life. Initially, if, for example, I take a person standing here on the ground, then he throws a ball onto this side, then the ball tries to go in this shape, then this is said to be a quadratic equation. Throwing of a ball or path of a projectile, this is called a projectile, which gives us a quadratic equation. So the first application is path of a projectile is a quadratic. Similarly, let's see, for example, I have, say, a rocket. Usually rockets go into the space from ground. Say I have a rocket which is out here, and once it is launched, then this tries to go straight into the sky, but we generally assume that it goes straight in the sky, but no, it doesn't go straight, but it goes in like this into the sky, and then it goes outside of sky everywhere, crossing the sky into the space, into the moon sometimes. Therefore, the launching of rocket, the moving of a rocket from the ground is also a quadratic, can also be represented using a quadratic, is one of the way of understanding the quadratics in real life. Also, there are many other applications. Say, for example, I take a vehicle. I have a vehicle, then when it is going very fast on the ground, then if I put the sudden brake, then the stopping distance is also a quadratic. The stopping distance of a vehicle is also a quadratic. Is representing a quadratic is how we understand the various applications of quadratics in real life. Even we have the reflecting mirror also one of the example of quadratic, because a reflecting mirror generally in the shape of a convex and plane on the other side is an example of a quadratic. Reflecting mirror also represents a quadratic equation. Similarly, the eyeglasses also sometimes, the contact lenses or the eyeglasses would also form the quadratic equation. When I take the glasses out here, this eyeglasses form a quadratic equation. Is how we see so many applications in branches of science in generally daily life connected to quadratic equations, which we are going to see in detail in the coming sessions. Now, let's see how we can convert the word problem into the quadratic form, or representing the given situational word problem into the quadratic form. So, for example, I have a problem which connects the right angled triangle with quadratics. So, the question says in a right angled triangle, the longest side is 25 centimeters and the difference of other two sides is 5 centimeters, then I have to find the other two sides, is the question. Then find the other two sides is the question out here. So this question is related to a right angled triangle. So let's draw a right angled triangle and see how quadratic equations can be utilized for this situational problem. So as the triangle here is right angled, so I take one of the angle as 90 and then draw a right angled triangle. Now also it is given that the longest side is 25. So obviously in a right angled triangle, hypotenuse is the longest side. Therefore, if I take the triangle as ABC, the right angled triangle ABC, then the longest side, which is the hypotenuse, would be a side opposite to 90 degrees, is 25 centimeters. BC is the hypotenuse, the longest side, and hence 25 centimeters. Also, it is given that the difference of other two sides is 5 centimeters. Therefore, if one of them, if I take it as x centimeters, then this would be x minus 5 centimeters. So the difference is 5. Therefore, one of them I take it as x plus 5 and one as x, because so that the difference of x plus 5 minus x would give me 5 centimeters. Is how I get the dimension. If one of them I take as x, the other would be x plus 5. The difference giving me 5 centimeters. Now with the dimensions of 25x and x plus 5, then I clearly use the Pythagoras theorem, the most important theorem connecting the right angled triangle with the sides, respective sides. Therefore, we know that by Pythagoras theorem, hypotenuse square is the sum of squares of other two sides. Therefore, hypotenuse square is the other two sides, which is AC square plus AB square. Therefore, this being hypotenuse as 25, I clearly get this as 25 square is AC, which is x square, plus AB, which is x plus 5 whole square. So let's see how a quadratic equation is generated from this Pythagoras condition. So if I simplify the right hand side, then this is a plus b whole square, which is a square plus 2ab plus b square, that equals 25 square. Further simplifying this, I get this to be x square plus x square, which is 2x square, then 2 times of 5, which is 10x, plus 25 equals 625, because 25 times 25 is 625, is how we get simplified statement. Continuing further, I get this to be 2x square plus 10x plus 25, and 625 I bring to the left, I get minus 625 coming to the left equal to 0. Now I just simplified this so that I get the simplified equation of this as 2x square plus 10x plus 25 minus 625 is negative times 600 equal to 0, is what I get. I can further simplify this by taking 2 common. Therefore, I get this as x square plus 5x minus 300, which is obtained by dividing 2 to each of the terms. The whole equation divided by 2 gives me x square plus 5x minus 300 equal to 0. Now this is said to be a quadratic equation in a variable x. This is a quadratic equation, and how to solve that? We have to solve this quadratic equation using the factors. So how do we find using the factors is the biggest question. So finding the factors for this, 300, I can write it as 20 times 15, which is 300, and 20 minus 15 is also 5. The factorization is already learnt in the lower classes. So as a recap, we had to factorize this, which gives me x square plus 20x minus 15x minus 300 equal to 0. So each of this as obtained from the factors of 300 as 20 times 15. Now let them be paired, pair 1 and pair 2, so that in pairs again I take something common. The possible things common out here is x with x plus 20, and here it is negative 15, which gives x plus 20 equals 0. So finally again I take x plus 20 common, which is the common factor in the first term and the second term. Therefore I get this as x plus 20 times x minus 15 equals 0, is how I get the factorization done. All the possible factors which are utilized to get the two factors. When the product of two factors is 0, each of the factor is assumed to be 0, such that implies factor 1 equal to 0 and factor 2 equal to 0. And then this gives me x equals negative 20 and x equals 15 is what we get. But I don't include this solution, but I include this because x is the length of the side, which cannot be negative. It should always be a positive value because length cannot be negative. The magnitude is always positive. Therefore, x is equal to 15, since x is the side and cannot be negative. Therefore, I get x equal to 15, but indirectly the question here is find the other two sides. I can find the sides. One of them is 15, the other is 15 plus 5. Therefore, AC is 15 centimeters, and my AB, which is x plus 5, is AB is x plus 5, which is 15 plus 5, which is 20 centimeters. So these are the other two sides of the right angle triangle. One side being 15 centimeters and the other side is 20 centimeters in a right angle triangle ABC, is how I understand the the concept. So the solution which we have obtained in the previous problem of a right angle triangle was the solving of a quadratic equation by factorization. So this is purely an example of solving the given quadratic equation by factorization method, where we found the factors of 300 which have been 15 times of 20, and then we add or subtract to find the factors. So there are various methods of factorizing the given quadratic equation. So how do we find the factors of a given quadratic equation? What are the different methods is what we are going to discuss. But before this, if I give an example problem where I want to test whether the given problem is quadratic or not is very important before we solve the quadratic. Identifying the equation to be quadratic is more important before we find the solution of that quadratic equation. So for example, I have an equation, say x squared plus 8x minus 11 is x minus 5 whole squared. Now I wanted to know if this equation is quadratic. So I need to simplify this, bring all variables and constants to the left and keep only 0 on the right. Until then, I cannot justify whether the given equation is quadratic or not a quadratic. So in this case, let me simplify this further so that I get x squared plus 8x minus 11 equals x minus 5 whole square is in the form of a minus b whole square. Therefore, this can be reduced as a squared minus 2ab plus b squared using a minus b whole square. To simplify further, I have this as x squared plus 8x minus 11 is x squared. This is 2 times of 5, which is 10. So minus 10x plus 5 squared, which is 25, is what we get. Now, as I see here, this x squared clearly gets cancelled, and then finally, when I bring all x and constants to the left, I get this as 8x minus 10x here becomes plus 10x minus 11, and plus 25 to the left is minus 25 equal to 0. This, on further simplification, gives 18x minus 26 equal to 0. Now, I say this is not a quadratic because there is no x square term. So, this is not a quadratic, and hence even the given problem is also assumed not to be a quadratic, since no x square term exists. There's no x square term in the given equation. Therefore, this is not a quadratic equation. Is how I understand the concept of quadratic equations. Now with this, once I identify that the given equation is quadratic, then the next task comes in how to find the solution of quadratic equations. The factorization method which is already dealt with. Now, how to find the solution of a quadratic equation, or initially to start with, what is the solution of a quadratic equation? What do you mean by solution of a quadratic equation? So let's start with the heading, solution of quadratic equation. So to start with the definition of solution, what is a solution of quadratic equation? It is the value of x which satisfies the quadratic equation. So solution is the value of x which satisfies the quadratic equation, is how we understand with the basic definition of solution. So we take the value of x, and when we substitute in the quadratic equation, it must equate to 0. Then we say that value of x is the solution of the given quadratic equation. So value of x which satisfies the quadratic equation is called the solution. Now, next coming to the values, these values of x are also called roots or zeros or solutions. So they have three different names. One is the roots, the zeros, or solutions. So when I say find the roots of the given quadratic equation is nothing but finding the values of x which satisfies the quadratic equation. If I say find the zeros of the quadratic equation, is nothing but finding the values of x which satisfy the quadratic equation. Or finding the solutions of the given quadratic equation is nothing but finding the values of x which satisfy the quadratic equation. So for example, if I take is this, then let me see the value of x which satisfies this equation, and that way x is either called the roots or the zeros or the solution. So clearly, let me start with the trial method. When I take x equal to 2, I get 2 squared minus 5 times of 2 plus 6 equal to 0 equal to, let's see what I get when I substitute in the left hand side. Then this is clearly 4 minus 10 plus 6, which is 10 minus 10 and 0. But because I get this equation to be 0 when I substitute x equal to 2, therefore I say is the root or solution or 0 of the given quadratic equation, is the root of the quadratic equation, this equal to 0 is how I understand the solution. But when I take x equal to 1, let's continue with this, which gives me 1 squared minus 5 times of 1 plus 6, and let's see if I get this equal to 0. This is 1 minus 5 plus 6 minus 4 is 2, which is not equal to 0. Therefore, x is equal to 1 is not the solution of this quadratic equation, is how I conclude. Is not the solution of x squared minus 5x plus 6 equal to 0, is how I understand between the solution and not the solution. So solution of a quadratic equation using with three different names. So now that we have discussed about solution of a quadratic equation in its most basic definition, let's see what are the various methods through which we can find the solution of a given quadratic equation. There are three important methods identified in mathematics for solving a quadratic equation. So to start with, the methods for finding the solution of quadratic equation, we have three basic methods in finding the solution of the quadratic equation. One is the first method called the factorization method. And secondly, complete square method, and thirdly, it is the discriminant formula method. It's called the discriminant method. So these are the three basic methods through which we get the solutions of given quadratic equation: the factorization method, complete square method, and discriminant method. So let's see each of them step by step. To start with the factorization method. So note, in each of the methods, a given problem, if it is given to use with particular method, we use only that particular method. If nothing is mentioned, the choice is left to the student to use any method which is easier in their own respective ways. So it's a very important note I make here that if the method is specifically mentioned, then use that method only. Then use only that method, because it is with the intention of using specifically with that method is how we are going to proceed. So initially, to start with the factorization method. So let's start with factorization method. How to solve a given quadratic equation using the factors or the factorization method. The first method, the factorization method. The factorization method is, the word itself states about factors. So we identify the factors and that helps us in solving the quadratic equation. So let me take an example problem and let's see how factorization method can be solved with that respective example problem. For example, I take an equation equals 1 by 6. Now this is directly not a quadratic because I have linear x and the power of x here is -1, which is non-negative integral. We have to make this a quadratic by further simplifying, and just let's see if we can test this for a quadratic equation. That's the first thing you must identify, that whether a given equation is quadratic or not. So let's see if this is quadratic or not a quadratic equation. To start with, I can take the LCM of x and 1 over 3x, which comes out as 3x. So this gets multiplied with 3x times of x is how we do the LCM part, and this with 1 times of 1, this equals 1 over 6 is how I get the LCM of x and 1 and 3x done out here. Next, x times of 3x is 3x squared minus 1 over 3x is 1 over 6 is how I get the simplified part of the above equation. Now this, on further simplification through cross multiplication, gives me 6 times of 3x squared minus 1 is 1 times of 3x, which needs to be further simplified. Therefore, when I expand this over the brackets, I get 6 times of 3 is 18x squared minus 6 is 3x. Then this, with all terms to the left and only 0 to be kept on the right, gives me 18x squared minus 3x minus 6 equal to 0, which can further be simplified by cancelling each of 3. So I divide the whole equation with the number 3 so that I get 18 by 3 as 36 x squared minus x minus 2 equal to 0. Because I divide whole of this equation with 3, I get 3 6 18, 3 1s minus x, 3 2s minus 2. Now this is clearly a quadratic equation which is obtained from the given problem. Therefore, I have to solve the given quadratic equation, and the roots or the solution of this quadratic equation is nothing but indirectly the solution of the given problem, is how we understand the concept. So let's see how we can solve the given quadratic equation using the factorization method. So the quadratic here is 6x squared minus x minus 2 equal to 0. Now the first rule in solving the factors for this given quadratic equation using the factorization method is that we always multiply the coefficient of x squared with the constant term. Always in any quadratic equation we multiply the coefficient of x square with the constant term. So I get this. Of course, I don't take the sign into consideration, but apart from sign, I just find the factors as 2l. Now next, I want to find all the possible factors of 2l, which I start with 1. Let me identify the value 2l with all its possible factors. Initially, 1 times of 2l is 2l. Next, 4 times of 3 is 2l. And 6 times of 2 is also 2l. So these are the possible factors for 2l. So once we identify all the possible factors, then we try to consider the middle value, which is the coefficient of x. Now here, the coefficient of x is -1. Therefore, when I add or subtract the factors, I need to get -1. So when I add 1 and 2l, I get 13. It doesn't work out here. When I subtract 1 from 2l, I get 11. Still, it doesn't work here. When I take 6 and 2, 6 plus 2 is 8. Doesn't work out here. 6 minus 2 also is 4, which doesn't work here. But when I take 4 plus 3, also it is 7. It doesn't work. But when I take 3 minus 4, it is -1, which works here. Because the coefficient of x here is -1. Therefore, these factors will help me in factorization. 3 minus 4 equal to -1. So this gives me 3 minus 4 equal to -1, which is nothing but the coefficient of x, which helps in factorization. This is how we identify the concept in factorization method. Therefore, when I split this, -x can be split as plus 3x minus 4x minus 2 equal to 0. Because 3x minus 4x is minus x. So indirectly, minus x, I can write it as 3x minus 4x, so that the factors 3 and 4 as obtained for 12 here will help in factorization. So indirectly, when I split x in the form of the factors of 12, then only factorization is possible through the factorization method. Very important to note here. So then next, I pair the first two and the last two together. The next concept is pairing them together, so that this pair, I can take 3x common. I need to take the maximum possible terms which I can take common out of this pair, which is 3x, which I can take common out of these two terms. So finally, when 3x is taken common, I get this to be 2x plus 1, which comes inside the brackets. Similarly, I can take -2 common out here, where the remaining terms inside would be 2x plus 1 equal to 0. Now sometimes there is a possibility that we do mistakes in taking the terms common. So it's very important that to recheck whether what we have taken common out here is right or wrong. Therefore, in order to recheck, I re-expand this to see whether I get the similar terms. 3x into 2x is 6x squared. 3x into x is 3x. So what I have taken common here is very much correct. It is about verification. Similarly, -2 times 2x is -4x, right? -2 times 1 is -2, so I'm right. So rechecking through the expansion for getting the original terms is very important here, because many students do mess up in doing mistakes in taking something common out here and here. So verification is a must. Make a note. Next, I find that the whole of 2x plus 1 is again common out of the first term and the second term taken on the whole. Therefore, this common term comes out of both the terms, so that the remaining terms, when 2x plus 1 comes out, then I have only 3x left inside, and this comes out, then only -2 is left inside, so that I get 2x plus 1 into 3x minus 2 equal to 0. Is how I get when the whole of 2x plus 1 is taken out. Now I have the product of two factors equal to 0. The product of two factors is 0 makes me understand through the factor theorem that each of the factor can be 0. Either this equal to 0 or this equal to 0 is the factor method. So that implies 2x plus 1 is 0 or 3x minus 2 is equal to 0. Either this equal to 0 or this equal to 0 is what, when combined, gives both product equal to 0. It's not compulsory that both of them should be 0. Even if one of them is 0, then 0 multiplied to any non-zero number will give back 0, is how we understand this factor concept. Next, when 2x plus 1 equal to 0, then what is the value of x? It's clearly minus 1 over 2. And then when 3x minus 2 equal to 0, then clearly I get 3x equal to 2. That implies x is 2 over 3 and x is minus 1 over 2. Therefore, solution of the given problem is x equal to minus 1 by 2 and 2 by 3, indirectly written in this form, or x equal to minus half and x equal to 2 over 3 are the required solutions of the given quadratic equation, indirectly, not in its quadratic form. The respective equation given as x minus 1 by 3x equal to 1 by 6 reduced to a quadratic equation and held solved using factorization method is how we do for any quadratic equation. Now, how do I know that the values which I have obtained are right or wrong? How do I verify? Verification. We verify this by substituting them in the equation back to see whether I get equal to 0 for the given equation. So I can substitute the value of x as this or this in either this equation or the original equation. So let's substitute in the original equation. My original equation out here says that x minus 1 over 3x is 1 over 6. So let me see if this first value of x equal to minus 1 by 2 satisfies this equation. So substituting x equals minus 1 over 2 in this, then let's see if I get the left hand side equal to the right hand side. My left hand side, which is x minus 1 over 3x, gives me x minus 1 over 3x is what I get. And when I simplify this, I must get the right hand side, which is 1 by 6. So let's see if this simplification leads to 1 by 6. Now here I get the LCM as 6, which 2 times of 3 times of 1 is minus 3, plus 3 times of 2, 2 times of 2 is 4, which finally gives me 4 minus 3 is 1 over 6, which is clearly the right hand side of the equation. Therefore, the value of x which I obtained is minus 1 by 2 is very much true or correct. Similarly, to know that the second value also is correct, equally I substitute x equal to 2 by 3. But before this, my x is minus 1 by 2 is fixed to be the solution of the given equation. So next, x equals 2 over 3 implies x minus 1 over 3x is 2 by 3 minus 1 over 3 times 2 by 3. This gets cancelled, and then finally I get 2 over 3 minus 1 over 2, which on simplification clearly gives 1 by 6. Therefore, the other solution which I obtained as 2 by 3 is also very much true to its best. This is how the verification is done for the given quadratic problem. Now, if the question is not specifically asked of verification, then this will be very time consuming, where I suggest you all to solve it very fastly on the rough notes and then check whether the answers you obtain are right or wrong, because time factor is very important when writing the examination. So this can be randomly checked without including the prolonged steps. So this is how the factorization method is used in finding the factors of the given quadratic equation. Now, in factorization method, the other important factor which we need to focus on is how we choose the factors. For the previous problem, it was quite easy to choose the factors, but sometimes the two different factors when added and subtracted give the same combination. Let's see how that can be overcome with an example problem. For example, I take the quadratic equation x squared minus 5x plus 6 equal to 0. Then, as we know that the factors are obtained for the multiplication of coefficient of x squared with constant, that is, when I take this with this, then I get 1 into 6 is 6. Then I find all the possible factors of 6. Then I see that the factors are 3 times of 2 and 1 times of 6, which give me the factors of 6. And interestingly, we need to see either when we add or subtract the factors, I must get the middle term, which is minus b, which is b and negative 5. So clearly I see that 3 plus 2 also gives me 5 and 6 minus 1 also gives me 5. So this is a case of a tie. So which one are we going to use? Are we going to use the factors 3 and 2 or 1 and 6 is the biggest question out here, because 3 plus 2 gives me 5 equally, 6 minus 1 also gives me 5. Now the puzzle comes out here. So let's also take both the things and see where the condition fails. If suppose I take here, for example, 1 and 6, then I can write this as minus 6x plus x, 1x plus 6 equal to 0 if this is split along the two factors minus 6 and 1. Again, let me take the second factors 3 and 2, where this can be split as minus 3x minus 2x plus 6 equal to 0 when I use these two factors. So when the factors 6 and 1 is split with minus 6 plus 1, which gives minus 5, and the factors 3 and 2 when split gives minus 3 minus 2, which is minus 5, both are equally the same. But which one helps me in factorization is very important out there. So which one do I use? Do I use this or this is the biggest question. In factorization method, the most important note is I use this and I don't use this. This cannot give me the factors by factorization method, but this gives me the factors in factorization method. Why? What is the reason? Because this equation has 2 even minus signs and 2 even plus signs, but this has 1 odd minus sign and 3 odd plus signs. If we have even minus or plus signs, we can factorize. If we have odd minus or plus signs, we cannot factorize. So a very important note comes here. Choose factors which yield even minus signs and even plus signs, that is 2 and 2, or 4 plus or 4 minus. So even number of minus or plus signs should be there in case of this. 1, 2 plus signs, 1, 2 minus signs. But here 1, 2, 3 plus signs and only 1 minus sign. So this is the case of odd, this is the case of even. Therefore choose factors which yield even plus signs or even minus signs, or all plus signs or all minus signs, but you cannot use when you have odd or plus or odd minus signs. So choose factors which yield even plus or even minus is very important in identifying the factors in factorization method. In this example being, this can be used for factors, this cannot be used for factors. This is how we identify in fact. For example, to start with the quadratic equation, say for example, I take x squared plus 4x minus 4 equal to 0. This is clearly a quadratic equation, but the factorization method may not be helpful out here. Say for example, I just multiply with the factorization method with 1 and 4, I get 4 to be the value for which the possible factors need to be identified. So let me use the possible factors 2 times of 2 which gives 4, and therefore the factorization is possible by taking 2 plus 2, which stands for coefficient of x, which is 4. So let's try to use the factorization method in splitting the middle term according to the factors of 4. So this can be further simplified to be split with the middle term 4x, which can be written as 2x plus 2x minus 4 equal to 0. So with all the possible factors identified here, this seems to work well. But the factorization method is not a success out here. The reason being that if I have, the rule says I need to have the even number of plus signs and even number of odd minus signs in the entire quadratic equation after splitting the middle term. But when I see the plus signs, 1, 2, 3 plus signs and 1 minus sign is an odd case out there. So there are 3 plus signs and 1 minus sign in case of this quadratic equation. Therefore, factorization is not possible. Factorization method fails. So in case of such quadratic equations, factorization method may not be a suitable choice. Therefore, for those kind of equations, we try to modify a more different method called the complete square method. A complete square method can be applied for such quadratic equations, and hence let's see how the complete square method can be used in solving of a given quadratic equation. Now before we start with the complete square method, there are many steps which we need to follow in finding out the solutions using the complete square method. So let's take an example problem and examine each of the steps on how the different steps need to be proceeded in finally solving to find the solutions of the given quadratic equation by complete square method. So initially, let me take a quadratic equation, say for example 5x squared minus 6x minus 2 equal to 0. As I clearly identify here that my coefficient of x squared is 5, coefficient of x is minus 6, and the constant term is minus 2. Now this I would like to solve using the complete square method. And hence what I would do is, the first step is I divide the whole equation by 5. The entire quadratic equation is divided by 5. The reason being that the step 1 says that I always need to make the coefficient of x squared to be 1. Divide by 5 to make the coefficient of x squared equal to 1 always. So any problem given out there, the first step or the first destination is to make the coefficient of x squared equal to 1. Therefore, because I have the coefficient of x squared is 5, I can make that equal to 1 until and unless I divide with 5, I don't get the coefficient of x squared equal to 1. Therefore, immediately I divide by 5, simply to make the coefficient of x squared equal to 1, the rule 1. This says the rule 1. So let's divide and see what finally I get. Equal to 0 by 5. Then this reduces to x squared minus 6 over 5 of x minus 2 over 5 equal to 0 is what I get. And now my destination of reaching the coefficient of x squared equal to 1 is finally reached out here. Now with this coefficient of x squared being 1, let's try to see how I can make this a complete square. As the method itself says complete square, my destination out here is to make this in the form of a square. Therefore, let's see how I can convert this into a perfect square or a complete square. Method is what it is about. So when I clearly see this is in the form of a square, and I can convert the formula a minus b whole square as a square minus 2ab plus b square. Therefore, in order to get a minus b whole square, I need to just see that this reduces to the form a square minus 2ab plus b square is the target out there. So therefore I have a square minus 6 I can write as 2 times of 3 by 5 into x minus 2 by 5 equal to 0. So the reason why I split this 6 into 2 times of 3 is because I want to reduce this into the form a square minus 2ab, and b square is the term missing out there. Therefore, this being b, I add and subtract the b square term so that I get a complete square. So let's see how we can do that. So a square minus 2ab written in order, and b square is not available here. So equally I add this b square term and subtract the b square term equally so that the whole equation doesn't get disturbed. So adding and subtracting the b square term is strictly because I want to reduce this into a perfect square, where the formula says a square minus 2ab plus b square is a minus b whole square. We all know that formula. So if this is reduced to the form a minus b whole square minus, this can be simplified with 9 by 25, because 3 square is 9 by 5 square is 25, minus 2 over 5 equals 0, is how we obtain the perfect square. So now this is where the perfect square is obtained. Now next step is about taking LCM and finally simplifying for the x and y. For x, the value of x. So let's see how we can continue further from here by taking LCM. Now let's take LCM on to these two constant terms so that I get x minus 3 over 5 whole square minus 25 being the LCM reduces to 1 times of 9 is minus 9, and this will be plus because I have taken minus common together from these two terms outside. So I get plus inside the bracket, and then 5 times of 5 is 25, and then 5 times of 2 is 10, is how I do the LCM of the two given numbers. Now then this reduces to an equation where the constant is taken to the right. Therefore from here this implies x minus 3 over 5 whole square will be equal to 10 plus 9, 19 over 25. Now this is further simplified by taking square to the right side, which reduces as a root. So when x minus 3 by 5 whole square is equal to 19 by 25, then that implies x minus 3 over 5 is equals to root 19 over 25. Of course, I get plus or minus out here, because when x squared is y, x is plus or minus root y. Remember, x squared equal to y implies x equals plus or minus root y, is a very important formula out here. When x squared is y, x is not root y, but it is plus or minus root y. Even the minus sign holds true along with the plus sign of root y. Therefore, I get plus or minus root 19 over 25. Therefore, simplifying this, I get this as x minus 3 over 5 is equal to plus or minus root 19 by root 25, which is 5. This constant on the left is again taken to the right with two values, where I get one of them with plus and one of them with minus. X minus 3 over 5 is root 19 over 5, and then again x minus 3 over 5 is minus root 19 over 5, is how I get one plus and one minus. Thus, one of the plus giving me one solution of x and one of the minus giving me two solutions, the second solution of x. Therefore, I'll get two solutions for a quadratic equation with degree equal to 2, at most two solutions. Now in this case, x would be root 19 over 5 plus 3 by 5, which comes out to be 3 plus root 19 over 5 is one of the solution, and then this reduces to x equals, this brought here will give me minus root 19 over 5 plus 3 over 5, which on LCM gives me the final answer as 3 minus root 19 over 5. Therefore, I get two solutions for the given quadratic equation, this and this, to be the roots or the zeros or the solution of the given quadratic equation using complete square method. So this is how we do the complete square method. Now sometimes there are quadratic equations in the form, say for example 3x squared minus 5x plus 2 equal to 0. Then in case of such quadratic equations, the complete square method also can be used, but need to be identified with the exact formula of a square minus 2ab plus b square, or a square plus 2ab plus b square with the respective formulae. Now in case of this, let's randomly check on how the complete square form can be done. Now for example, I have this quadratic equation 3x squared minus 5x plus 2. Then the first step of using the complete square method is that I need to make the coefficient of x squared equal to 1. Therefore, I divide the whole equation with 3 so that I get x squared minus 5 over 3x plus 2 over 3 equals 0. This is how I get the quadratic equation reduced with coefficient of x squared equal to 1. But here, as I observe, this is in the form of a squared, but I don't have 2ab. There's no term 2 multiplied to this. Therefore, I need 2. So what do I need to do? In this case, what I do is I write in the form 2ab. I reduce this to 6 because I multiply with 2 and divide with 2, so that this becomes strictly in the form of a formula a squared minus 2ab. Whereas this, again on simplification, gives back the original term 5 over 3 of x. So cancelling 2 1s and 2 3s, again I get back 5 over 3 of x. And the reason why I multiply here is that I have the formula a minus b whole square equals a square minus 2ab plus b square. Now this being a square, I need 2ab, and hence the 2 is multiplied. It is essential and very much needed to multiply 2 and equally divide with 2. Plus 2ab is there, but again I need b square to make this a perfect square. So I just add b square and subtract b square as I have done in the previous problem. So adding of b square and subtracting of b square with the original term 2 by 3 undisturbed will make this to be a perfect square, is how we understand the perfect square method. So in this case, this reduces to x minus 5 over 6 of whole square, and then this reduces to minus 25 of 36 plus 2 over 3 equal to 0, and thus we proceed as we have done here. But the most important part of this method is to identify the coefficient of x squared and then reducing this to a complete square form, either by using the formula a minus b whole square or a plus b whole square, is a very important note for this method, the complete square method. Now the third method of solving the quadratic equations is the discriminant method. The two other methods we have seen were the factorization method and the complete square method. Now the discriminant method is the most powerful method because this doesn't have any restrictions. This method can be used for any quadratic equation irrespective of splitting in factors or making it a complete square. So this is identified as the most powerful method in solving the quadratic equations. And let's see how it is done. It is done with the use of a formula which we are going to see in discriminant method. Say I take the general quadratic equation or the standard quadratic equation ax squared plus bx plus c. If my quadratic equation is ax squared plus bx plus c equal to 0 with a not equal to 0 and a, b, c are all real numbers, then it has two roots. We all know that this quadratic equation with the degree 2 has at the most two roots, and the two roots are given by the formula x equals minus b plus or minus root of delta by 2a. where one of the root is with plus and one of the root is with minus. So when I take this split as plus and minus, I get x equals minus b plus root delta by 2a, and here one of them is minus root delta by 2a, where delta is b square minus 4ac and is called the discriminant. This value of delta is called discriminant. Is how we identify the formulae of finding the solutions of any quadratic equation using the discriminant method. Now this has a very significant role to play in quadratic equations. This decides the nature of roots or the nature of solutions which you obtain, and we will see this in brief in the future sessions. But discriminant has a very important role to play in quadratic equations. The two of the roots given by this formula and this formula finally identified to be this. So let's see an example problem where this can be applied. This formula can be applied where the two solutions are obtained. Now let's take an example problem to study the discriminant method of finding the roots. So for example, I take a quadratic equation 2x squared minus 2 root 2 of x plus 1 equal to 0. Then I need to find the roots of this quadratic equation. Now if I compare this quadratic equation with the general form ax squared plus bx plus c, then I clearly identify that the value of a is 2 and the value of b is minus 2 root 2 and the value of c is 1, because ax squared plus bx plus c, where a is this, b is this and c is this. Now to find the roots using the discriminant method, initially I need to find the discriminant delta. So as we know that the discriminant delta is given by the formula b squared minus 4ac, then I simply substitute the values of a, b, c in this equation and I get the value of delta. So first, finding the value of delta is very important in discriminant method. So let's find delta in the initial case of solving the given quadratic equation. So this, when substituted with a, b, c respectively, my b is minus 2 root 2 whole square minus 4 times a times c, which is 1, is how I substitute b squared minus 4ac. Now this, on multiplying twice, because this is square, I get 4 times, because 2 square is 4 and root 2 whole square is 2, because root x into root x is always x. This is very important to identify. Root x into root x is always x. Minus 4 times of 2, which is 8. And then finally I get this to be 8 minus 8, which is 0. Therefore the value of discriminant or delta is 0. Now let's come to the formula. We have seen the formula for discriminant method, which says that the roots of any quadratic equation in its general form is given by the formula x equals minus b plus or minus root delta by 2a, is the formula which we have taken in the previous session. Now let's try to substitute each of a, b and delta in this given formula and then find the values of x, which are the solutions of given quadratic equation. Now in this case, b is minus 2 root 2, so minus of b plus or minus root of delta by 2a is how I get when I substitute the two values. This gives me 2 root 2 plus or minus 0 by 4, which is 2 root 2 by 4. So this is root 2 over 2, and therefore I get the values of x, which is root 2 over 2 can be written as root 2 over 2 can be written as root 2 whole square, because root x whole square is x. So x can be written as root x whole square, which is nothing but indirectly in this form so that I can cancel one of the root 2. The reason I write 2 as root 2 whole square is I want to cancel this, which gives me x equals is the required solution. Why is the need to write this twice? Because if we get one root, that indicates that the roots are repeated. In case of this, since it has two roots, one of the root is obtained which is repeated again. So this example quadratic equation is said to have the repeated roots in the discriminant method, is how we understand using of discriminant formula in finding the quadratic equation, where this is called the discriminant formula. This formula is called the discriminant formula for finding the quadratic equations using the delta, which is the discriminant. So now that we have seen all the three methods in finding the solution of a quadratic equation in their respective processes, now let's see the last method which we have seen, the discriminant method, continued with this, because the nature of roots which we were talking